Exactly, because the inner shell holds one pair. All right, so cool. So thank you. So the we've got to get 6 electrons total. So the inner shell is going to look like this. It's going to have a pair. There's many ways to draw this, but that's one. So we're going to have to go for the outer shell. And the easiest way to draw where the pairs go for those is sort of north, south, east, and west. All right? So let me get another person for how those are going to be laid out. So we got, well, how many electrons do we have to put in that outer shell? Just everybody. 4 left, all right? And there's 4 pair slots, all right? So my question is, Nan, Lee, are you here? Nan, where are you? Where are you? Not, are you? You're here, your clicker's here. As a reminder, that's a bad thing. If you can always pass, but if your clicker's here and you're not, there's a penalty of 1 point for doing that because maybe you sent your clicker in without yourself, which is a bad thing. All right, let's do it this way then. So are we talking 2 pairs, 4 in one place, 4 lone ones? What's the deal? Shout it out. What's the 4 lone ones? That's right. So we can draw it like, there's several ways again to draw it. There's going to be 4 electrons and 4 empty seats, if you like. All right? And so this is we might call this an opening. So there's lots of empty seats on the bus. So the idea is there's 4 openings in the outer shell. Also 4 electrons in the outer shell. Therefore, we'll want, if you like, to form 4 covalent bonds. And you could draw a carbon like this, if you liked. So the carbon, to get its full shell, it needs 8. If we could share 1 here, 1 north, 1 south, 1 east, and 1 west. They aren't really north, south, east, and west, but if they could share 4 that way, then this would be a happy atom. It would have 8 electrons in its outer shell. So carbon likes to make 4 covalent bonds. It turns out, for what it's worth, its kernel charge is equal to 6 pluses in the nucleus minus 2 electrons in the inner shell gives a plus 4 kernel charge. So it turns out this is moderately electronegative. Now, you could not know that. You can't predict that 4 means moderate. I'll have to tell you that, right? We can do comparative things. Questions? Then we'll do another one. Things get a little more complicated. Yeah. Pardon me? Oh, you want to see up above there? All right, I think I can do that. Let me see. So you want to see that stuff there? All right. Other questions? Yeah. What did I do with the 6 minus 2? All right, so that I got to scroll down. Sorry about that. The kernel charge is the positive charge on the nucleus. Take away the charge on the inner shell electron. So the nucleus, the grain of sand, is plus 6. You got 2 minuses circling. So the back row, what do they see? Plus 4. 6 minus 2. All right. Let's do one more, and again, talk to your neighbor. It's a slightly more complicated one. Oxygen. And oxygen's deal is it's got 8 protons and it's got 7 neutrons in the nucleus. So same deal. Figure it out, talk to your neighbor. I'm going to want to know, but now I've upped the ante, right? Not only electronic structure, but can you predict from that how many covalent bonds is it going to want to make? And is it going to be more or less electronegative than carbon? So relatively speaking. So first structure, and from that you can then conclude number of covalent bonds, and then you can also conclude more or less electronegative. So take your time, puzzle it out. We'll get down to business.